Hi guys, this is Intro to Polynomials, and in this section we will do determining degrees of polynomials, adding and subtracting polynomials, evaluating a polynomial for a given function, and adding and subtracting polynomial functions. And we'll go over most of the stuff that is relevant to what you guys have in the homework here. So we're going to actually skip through all of this. So just some general information. A monomial. A monomial is an algebraic expression with one term. So mon, one, so one polynomial. It just looks like ax to the m. We'll see some examples later. Polynomials can be described as polynomial, a monomial, or two or more algebraic terms combined by addition and subtraction is a polynomial. So polynomial, just think multinomial. We have here a monomial, polynomial with exactly one term, binomial, a polynomial with exactly two terms, a trinomial, a polynomial with exactly three terms, and here are our examples. So as we look down, I can't scroll, here we go. Oh, can I go down more? There we go. Does that work? That works. Okay. Oh, we go, oh, nope, I don't want to go back and forth. There we go. Alright, here are some polynomials. So, row 1, polynomial. Here's some examples. So, just polynomials, again, many monomials squished together. Monomial single term, 14, 8y squared, one term. Notice there's no addition or conjoining more than one term. That's it. Binomial, two terms put together, two terms put together, two terms put together, two terms put together with either addition or subtraction. Trinomial, three terms put together with addition or subtraction. Three terms. So everything in this list is a polynomial. The degree of a polynomial, this is just going to kind of be for your information. We're not going to be asked questions on this. The degree of a term is the sum of the exponents of its variables. The degree of a constant term is 0, and the degree of the polynomial is the highest degree of all of its terms. So if we scroll down here and look at some examples, 14 has degree 0 because there's no exponents and variables there. AB squared has a degree of 3 because A has degree 1, B has degree 2, add those together. This term here has degree 3 plus 5, so 8. This term here has degree 1 because A to the first power. This binomial, the degree of each term, degree 1, degree 0, so degree of the polynomial is 1. Degree 2, degree 1, degree of the polynomial is 2. Degree 4, degree 0, polynomial has degree 4. So the degree of the polynomial is always the degree of the greatest term in the polynomial. Like we'll take this really long guy down here. That's degree 4, degree 3, degree 2, degree 1, and then degree 0. So the largest degree that we have of all the terms is 4. So the degree of the polynomial is 4. Alright, so let's determine whether each of the polynomials is a monomial, binomial, trinomial, or other. So example 1, how many terms do we see? 1, 2, 3 terms. Therefore, it's a trinomial. How many terms do we see here? Well, this is just one term. It's one giant block, so it's a monomial. This guy here, we have 1, 2, 3, 4, 5 terms, so we would just call it a polynomial. Anything after 3 we just call polynomial. D, one term, two term, binomial. E, one term, monomial. Good. Alright, we're going to keep going down now to adding and subtracting polynomials. Alright, so how do we add or subtract these guys? Now I'm going to take my pen out. So, adding or subtracting, what we look for, here are your steps. You just combine all like terms, and you just consistently just keep combining like terms until you're done. So, our like terms here are y squared, and then we just combine our coefficients. 25 plus 15 is 40, and we're done. For these guys here, to be a like term, we need the exact same variables with the exact same exponents. We need matching variables with matching exponents. So a pq to the third can only combine with another pq to the third. Oh look, pq to the third here, pq to the third here. These guys can combine. So I take 16 and minus 7. So that's going to turn into a plus. 16 plus 7 is 23, and that's what we get down here. Let's scroll up and go to some more examples. So again, adding and subtracting polynomials is simply a big exercise in combining like terms. So let's look at A and B here. Alright, to add these guys, so that's an A squared, that's a B squared, so I can't combine it, but that's another A squared there. So that's a 1A squared, that's a negative 6A squared, so 1 minus 6, that's negative 5A squared. The B squared has nobody to play with, so that just gets to come along for the ride. And that's it. So that would be the simplified version of that polynomial there. Trash that. So what about this guy? Okay, we need a u squared v. Is there any other u squared v's? No. So Mr. Lonely just comes by himself. Okay, there's a u squared here. Is there any other u squared? No. So that term again just kind of gets copied down. Is there any more v squareds? Nope. So same thing. So this polynomial here is it. We couldn't add or subtract anything. It's unchanged because there is no like terms. So that guy just is what it is. Alright, let's try some more. Let's try this example here. Okay, so let's underline all the like terms first. Okay, y squareds get to combine with other y squareds. Okay. Oh, no, I want a different color. There we go. Single y's get to combine with other single y's. And constants get to combine with constants. So when we add all these guys up together, actually I'll keep the black. So 7y squared plus 4y squared, so that would give us 11y squared. Negative 2y plus 8y, that would give us minus 10y. Positive 9 plus negative 7, that would give us a negative, or sorry, positive 2, because 9 minus 7 is positive 2, sorry. So we would end up 11y squared minus 10y plus 2, and then we'd be done. So again, exercise in combining like terms. Let's find some other ones. I want to do a really good subtraction one. Here we go. So example 5, find the difference. So same thing. We're going to find all of our like terms. So here's a w squared here. Here's a w squared here. Let's go to more fun colors. Here's a w here. There's no more w, so that's the only w here. Let's go for that green. It's kind of fun. And then here's a constant here, and here's a constant here. So now we need to be careful, though, because if there is a subtraction in the middle. So let's go back to black. Alright, 9y squared, so we basically have 9 minus 2. Okay, so that's 7, and this was for the w squareds. Negative 7w, there's nobody else for that guy to play with, so he is by, or she, I guess, is by himself, herself. It is by itself. 5, so now constants, 5 minus negative 4. So we have a minus, so this is actually going to go plus. So 5 minus negative 4, that'll end up being a plus 9. And that'll be our combined polynomial here. Alright, moving on. Let me see if I can find like a really challenging one. Find difference? No, not good enough. Let's go try it number 11 because that guy looks fun. Okay, first thing I'm going to do is I'm going to I want my pen, not my lines. I'm going to rewrite this. So when it says subtract this from that, that is actually saying that I want a squared plus b squared minus a squared plus 5ab minus 6b squared. Because if I'm subtracting this from that, that means we basically reverse the order and put a subtraction in the middle. So if now I'm going to go through and find my like terms. Hey, there's an a squared here, there's an a squared here, there's a b squared there, there's a b squared there, but there's a 5ab there. That has nobody to play with. Okay, so let's go through and combine. So a squared minus a squared, 0. B squared minus negative 6b squared. So minus minus, so that's going to turn to a plus 7b squared. And then, so our a squareds are done, our b squareds are done. So now we have this minus outside, 5ab. You've always got to take into account that minus. So this actually cleaned up a little bit, 7b squared minus 5ab. And that would be our final polynomial there after we've added and subtracted. Let's clear that and let's see if we can find any more useful examples. Find the sum, so we would just combine like terms, add together. Find the sum, simplify. Oh, this guy looks interesting. So let's do this guy, because this guy looks like fun. So combine all the like terms. So simplify. A cubes. Is there any other a cubes out there? No. Alright, change colors. Let's go gray. A squared b's. Is there any other a squared b's? Yep, there's one more a squared b. Okay. Change color. A b squareds. Is there any other a b squareds? Yep, there's one right there. And then b cubes look like you're all by yourself. No, that's too close to the other color. It's green. There we go. Okay. Let's go back to black. Alright, combine time. A cubed, there's nobody to play with, so that's just going to be a cubed. Negative a squared b, so there's negative one of these right now. Here's the other one. So negative one of these plus one, so these guys are combining. Negative 1 plus 1, these guys actually cancel out completely, so that's going to be a 0. And let's see, negative ab squared plus ab squared, so that's a positive 1, that's a negative 1, same thing. These guys actually canceled out. And then this negative applies to this b squared, or sorry, b cubed, so this is actually minus b cubed, and that's the final answer for that guy. Okay, let's plug some stuff into some other stuff. So create a polynomial function evaluate a polynomial function for a given value. So this is just more of the plug-in stuff that we've done before. But if we look at example 9, so for the function f of x, and I'm right here, f of x equals 5x squared minus 8x plus 4, find f of 4, f of negative 2, and f of 0. We've done this before. We just plug in the values into x. So, for instance, for a, here's f of x. Notice all the 4's are substituting in where the x's were. And then evaluate. That's it. For b, same thing. b, we're finding f of negative 2, so substitute negative 2 in everywhere you see an x. Here are my x spots. Therefore, they are now getting negative 2's and then evaluating. Okay, so just a quick review on evaluating, because we've done this before and I feel like sometimes we do this to death. So, see, find f of 0, plug in 0 everywhere you see an x. In this case, everything gets to go away except for the 4, so f of 0 in this case would be 4, also known as intercepts. So, that's basically it. Same thing for example 10. Find h of 2, substitute 2 in everywhere you see a t in this case for this particular polynomial, and then you would find the height after 2 seconds. That's it. That's all we're doing, just more evaluating. Go back to my, oh no, come back. Go back to my cursor. Alright, if you still have any questions on any of this, send me an email, give me a question. If you're in my class right now, raise your hand. And that's it. Hope you liked it.